In this lesson, we'll learn about named entity recognition, or NER. Named entity recognition is the process of finding and labeling essential pieces of information in text, such as names of people, places, organizations, dates, or quantities. For example, in the sentence Emma lives in London, NER would tag Emma as a person and London as a location. But this goes beyond simply finding capitalized words to capture the names. NER uses a combination of rules and machine learning to discover the entities. While capital letters are one clue, the model also looks at the surrounding context, word patterns, and statistical probabilities. This way, Apple might be tagged as a fruit in one sentence, but as a company in another. This makes NER a powerful tool for turning unstructured text into structured information that can be searched, analyzed, or used in applications like chatbots, question answering, and recommendation systems. To perform named entity recognition in Python, we'll continue using the spaCy package, which comes with powerful pre-trained models for this task. We also import displaCy from spaCy, which is its built-in visualization tool that lets us see entities highlighted directly in the text. Next, we import the tokenizer from spaCy, which breaks text into tokens so that spaCy can process it correctly. Finally, we bring in HTML and display from IPython, which will let us render visualizations inside our notebook. Okay, we start by loading our spaCy model, the engine that will process the text for named entity recognition. We create a variable called NLP and set it equal to spaCy.load, with the model name inside the parentheses. In this case, we're using the small English model EN-Core Web SM. Now, the NLP variable holds our spaCy model, ready to process text and identify entities. The example text we will use is taken from the Google Wikipedia page. We assign it to the variable Google text and print it to have a look. Next, we create a spaCy document by passing our text into the NLP model. When we do this, spaCy breaks the text into tokens, analyzes the grammar, and looks for named entities. But creating the document alone doesn't show us the entities yet. To see what spaCy has found, we need to loop through them. spaCy stores all the entities it detects in an attribute called spaCydoc.ents. So we write a for loop that goes through each entity in spaCydoc.ents. Inside the loop, we print the text of the entity with word.text and its label with word.label. You might notice that this attribute has an underscore at the end. In spaCy, label, without the underscore, gives a numeric ID of the entity, while label, with underscore, gives the human-readable label, such as person or organization. Okay, let's run the cell. Yes, we can now see which parts of the text are detected as dates, which are identified as people, which are classified as organizations, and which belong to other categories. Let's go a step further and visualize the different entities directly within our text. To achieve this, we use the displaCy.render function, which highlights entities and assigns each category a distinct color, making people, organizations, and locations easy to distinguish. displaCy.render takes our spaCy document and creates an HTML version of it with the entities highlighted. We save that into a variable called HTML. Inside the parentheses, we pass in 3 arguments. The first one is the document with the text that spaCy has already analyzed for entities. The second argument is style equals entities. This tells spaCy that we want to visualize entities specifically, since displaCy can also visualize other elements. The third argument is Jupyter equals false. This means instead of trying to display the visualization automatically in a Jupyter notebook, return it as HTML code, That way we can decide how and where to display it. All that output is stored in the variable HTML. So we wrap it with the HTML class to tell Python, treat this string as HTML content, not plain text. Finally, we pass it into display to see our text with the entities highlighted in different colours. Beautiful. We see the different entities grouped in separate colours. For example, all persons are in purple and all dates in green. Let's observe what happens to named entity recognition once we clean the text by removing punctuation and converting it to lowercase. We create a cleaned version of the Google text using the re.sub function to remove punctuation and then apply the lower method. Once we print this out, it looks a bit different. The punctuation is gone and it's all in lowercase. So we create a new spacey document with our clean text and we name it spacey.clean. Again, we iterate through each word in our new spacey document and print out each word and its associated entity tags. You can see that fewer entities are detected because of the lack of punctuation and capitalization. We can again use the displacey.render function to visualize the entities in the clean text. Yes, we see that there are fewer compared to our previous visualization. When we removed capitalization, the model lost a vital clue that helps it recognize names of people, places, or organizations. By removing punctuation, we also disrupted the sentence boundaries that depend on it to be recognized correctly. That's why it's essential to think carefully about when you perform named entity recognition in your data cleaning pipeline. As you see, if you clean the text too aggressively before running NER, for example, by removing punctuation or converting everything to lowercase, the model may struggle to recognize certain entities. One option is to run NER on the raw text first. Another one is to try some light pre-processing, then test NER again. In some cases, pre-processing can help the model pick up additional entities. The key takeaway is to familiarize yourself with your data, understand its content, and experiment with where NER fits best in your pipeline. That way, you avoid losing important information during cleaning.